This video will give examples of careers in precious metals using chemistry, chemical engineering, metallurgical engineering, and others. Our previous video reviewed the pyrometallurgical processes of calcination and oxidation roasting. Reactive gas refining are processes using chemical reactions with some of the metals within an alloy to convert them to a salt or compound. The Miller process and the pressurized carbonyl process are examples of this. The Miller process was patented in 1867 and is still a very effective process for stripping out silver and base metal impurities from high-grade gold alloys such as doré produced by many mining operations and high-grade jewelry scrap. This is done by bubbling pure chlorine gas through molten gold, which reacts with the silver and base metals, forming chloride salts. These salts are insoluble in the molten gold and skim from the surface, leaving at minimum 98% pure gold. The pressurized carbonyl process is used in platinum refining to strip out nickel as nickel carbonyl and leaving residues rich in platinum group metals. Smelting is a reduction melting pyrometallurgical process used to reduce a salt of a metal to its metallic form. For example, silver chloride precipitate can be reduced to silver by melting with zinc powder or sodium carbonate. Silver chloride contained in slag is also reduced in hydrogen-containing atmospheres. The platinum salt precipitate, ammonium hexachloroplatinate, can be converted in a hydrogen-reducing atmosphere to form a platinum sponge of 98% purity. Fusion melting is the melting of metal and molten salt mixtures to form various metal salts. For example, the platinum group metals that were not dissolved in aqua regia are fused melted with litharge, or lead oxide, soda ash, borax, and carbon, which chemically react to form a lead alloy containing all of the precious metals. When gold and silver ores are precipitated out from solution with the base metals such as zinc, the remaining solids contain 10 to 40% zinc. The zinc can be removed by melting and oxidizing using glass-like fluxes such as soda ash, silica, and borate. The zinc oxide forms and is dissolved in the molten salt or slag. The slag floats to the top for removal, and a 96% gold-silver alloy is obtained for further refining. Fusion melting by adding other salts can also transform non-soluble salts from a previously processed flux to specific salts that can be leached out. This is how rhodium, osmium, ruthenium, and iridium are refined. Cupellation is a form of reduction melting where the lead is oxidized into a molten salt, which is then dissolved into the porous ceramic walls. This leaves a precious metal bead behind. Assay labs routinely use cupellation on a small scale in the fire assay process for determining precious metal contents. Although pyrometallurgical extraction methods have been around much longer than hydrometallurgy, these sciences continue to be advanced at IPMI member companies and universities around the world. At the end of these processes, the result is a pure precious metal, whether it's gold, silver, platinum, palladium, rhodium, or one of the other platinum group metals. The purity expected at the end of these processes is at minimum 395, and for specific purposes, whether banking and trading, alloy, or pharmaceutical manufacture, the purity level required may be as high as 5 nines plus. The International Precious Metals Institute promotes the education and advancement of precious metals technology and business. IPMI is an international association of companies committed to providing technical resources and educational materials, including a series of videos presenting examples of precious metal applications and a variety of interesting and rewarding career opportunities.